I'm sitting here waiting for the next song to start. When it's time for lecture to start. So this week we're doing examples and demos. I have deployment with Docker Compose here, but it's more so going to be an open-ended demos week, whatever is appropriate for each day. Today is going to be the promised walkthrough of AO3 on homework 4. So homework 4, the laptop does not want to run Docker right now. It's running it, but the fan's spinning up. It's taking up resources. So AO3 is adding HTTPS to our app. We're going to do this using Nginx with a self-signed certificate, using Nginx as a reverse proxy, and listen on both ports 443. I say both ports, but I don't specify what the ports are. Do I have edit access right here? Oh, 80. Oh, there it is. Oh, I'm just blind. So we're going to listen on both ports 80 and 443. So if somebody tries to connect to us with HTTP, we're going to redirect them to HTTPS. And we're going to set all that up with Nginx. So let's do a walkthrough of how exactly to do application objective 3. We've seen all the parts of this in different lectures, but today we're just going to put it all together and just walk through exactly what I expect. As I said before, since I'm doing a walkthrough, this should be a free one, but at the same time, one character, it might happen during the demo. It happened last semester, which was kind of fun because I got to explain what can happen. But one character off in your configuration, and the whole thing will blow up. So there are still things that can go wrong. It's not completely free, but I will show you how to do it. Just real quick, we have the team project reports checkpoint. The feedback is on Autolab, so you probably all saw it by now. But that feedback is back, is out there, and by this Wednesday, 2 days from now, is your deadline to sign up for a presentation time. So if you don't have a presentation time by Wednesday night, you'll just get a random time. There's not too many left. There's two left for Monday. Oh, the one on Wednesday just went away. 2 left on Monday, and a whole bunch on final exam day. A lot of y'all don't want final exam day, but 2 more teams will get not final exam day, and everyone else, if you're not signing up for something, you can pretty much count on, it looks like, coming to the final exam time and presenting at that point. And another reminder with the presentation, you can get credit on the presentation without having your features for your app fully implemented. You have to have something, there has to be something that's deployed and running, so you have something to demo. But it doesn't have to be fully functional. All your features don't have to be there. As long as there's something there that we can use and see during the demo, you can still get full credit on the presentation without all of the features fully implemented. And I really have to do that because the project deadline's the 12th, but some of you will be presenting on the 8th. I can't expect you to have the project completely done by your project presentation time. So that's the reason why that's the policy. You can get full credit on it. That probably would be the policy anyway, to be honest. So you don't get hit multiple times. If there's one bug that you can't figure out, I don't want you to get hit twice with it. Okay. Let's do this. Oh, if my number visit counter. This is what your visit counter should look like. I think that was pretty clear from the description, but anyway, visit counter. So I have my app running. Oops, hit the wrong button, of course. So I have my app running. I use Docker Compose. I have a Mongo image, and I have my app running the way that we have all semester. So let's start from here and then build out our functionality from this. So we want to add HTTPS to this. First, I'm going to stop my Docker container. I guess I didn't have to get that aggressive with it. And write this stuff. What are the report checkpoints scored out of? One of our reports is 2 out of 1. It's out of 3. What do you mean 2 out of 1? Your reports are graded out of 3, just like the homework objectives. If you have a 2 or a 3, that means the report's done and you get the AO. If you get a 0 or a 1, you don't get the AO and you got work to do. 2 out of 1, I don't know what that means. On Autolab it says out of 1. Oh, maybe I didn't double check that out to see, but it's out of 3. If you, well, I don't have to go down this, but it's out of 3. I'll fix that. I'll update that. I probably put out of 1 thinking an application objective, and then think of the 0 through 3 grading, setting up the questions. Okay. So we want to switch this to use Nginx as a reverse proxy with HTTPS and redirect HTTP to HTTPS. Let's do all of that. So some of this we did last time, but we'll do it again just for completeness, just so this lecture has everything self-contained. And I'm doing this in PyCharm with my other app instead of the one we used in VS Code last time, because, I don't know, VS Code was frustrating me a little bit. But we're going to, in our Docker Compose, add our Nginx service, which I think was a problem with me, not a problem with VS Code. But we're going to add the Nginx service that's going to run through our Docker Compose file, and we're going to build this the same, similar way we do our app, but instead of just doing a dot means look in the current directory for a Docker file. We looked in our current directory, got the Docker file for our app. Instead, we're going to add a different directory. We're going to start at the current directory, but then we're going to go to the Nginx directory and say, look there for a Docker file. And in this, let me collapse this one. And in this directory, that's where we're going to add all of our Nginx configuration. So we're going to build Nginx, and then we're going to map some ports. Nginx is going to want port 80. And port 443. And we're going to map them onto the same port numbers. So in Nginx, we're going to run it 80 and 443 and map localhost 80 and 443 over to Nginx, and Nginx is going to take it from there. So we have Nginx set up with 80 and 443, and that's all the configuration we need here. Now we're ready to go into our Nginx directory. We're going to create a Docker file to see how we should set up Nginx. We're going to do from Nginx. I'll try to not forget the same things I forgot last time. I think it's just from Nginx, and we didn't have to specify a version. I'll just end up getting the latest. And we're going to not forget to copy in our configuration, so I'm going to do it right now. We have our configuration file, which was default.conf, which will have config for Nginx. And we're going to copy that in. We're going to do /default.conf and copy this into the container. And we have to copy this into a very specific location. We're going to start at the root. That leading slash is very important, like we talked about last time. We're going to start at the root, go to etc nginx conf.d. I'll double check that. I'm pretty sure it's conf.d. Default.conf. So that's where Nginx is expecting to see that configuration file. So we're going to copy that configuration file into that directory. Let me just cheat a little bit. Yeah, it's exact. Conf.d. I think it's for conf daemon, if I were to guess. That's going to get our configuration in there. And let's do server. We're going to listen. Let's just set up port 80 for now. Listen on port 80 And then location, whenever I get a request for any path at all, I'm going to proxy pass to whatever I named my app here. And you know what, just for the sake of making this point, my cool app. I'm going to name it my cool app. So that's going to be the host. I'm going to use HTTP because my app only speaks HTTP. We're not going to have our app speak HTTPS. That was just for an example on Friday. Our app is only going to speak HTTP, and it's listening on port 8000. This is going inside the container. So we're going inside the container. We need the port that we're listening to inside the container. I have that code here, but I have secure set to false, so I'm just going to listen. I'm not setting up the HTTPS on this one, but I happen to have it set up in case I want to switch that. But we're listening on port 8000 inside the container. So if we're using that host name, that's going to that container, routing this message to that container, and then going to the port that's listening on. Some of you started listening on port 8080, so you don't have to think about the difference between local port and container port. But if you're using 8000 still inside your container or any other port that you chose, make sure you have that port matching the port inside the container. So there are some things that are going to be different from my demo, of course. So proxy pass, and then I think it's proxy HTTP version. You know what? I'm just going to try this without using my cheat sheet and see if it blows up or not. Version 1.1, and I did forget my semicolons. So this should be enough setup to get Nginx listening on port 80 and then forwarding that traffic to my app. So if we run Docker Compose again, I'm not super confident. We might see some errors. We might see some things not work here. Let's see. Because again, one character in here and it just won't work. So if it's not proxy HTTP version, if it's HTTP version proxy, I'll be dead in the water. While that's running, I don't want to just watch Docker. I'm going to go to my DigitalOcean, get my IP address because I tried to go to this last time and found out that my history was deleted. I didn't want to go here and get my IP address on Friday. But let's get my IP address while we're waiting on Docker. Do we need to include Nginx in the requirements.txt file? No. So our code, like your actual Python code, is completely unaware that Nginx is even being used. Nginx is forwarding messages to your server, but from your server's perspective, it's just getting requests from a client. That client happens to be Nginx, which is forwarding a request from a user of your app, but your app doesn't care. It's just getting an HTTP request over a TCP socket, and that's it. It doesn't have to think about anything else. Okay, so our app's running. On port 8080, this should still work. We didn't change anything with that configuration, but the moment of truth, let's see if we can get rid of the port so it'll default to port 80 and see if we can route through Nginx, and hey, we actually did. So now we're routing through Nginx to get this request. And if we look at our requests, it's always, no, actually that won't be interesting, will it? But our requests are going to come from Nginx instead of from our browser, but it's going to forward our browser headers to us. But it won't forward every browser header. Actually, let's do this. If I go to web RTC. Yeah, you can use my camera. Refresh. Oh. I expected that not to work. Well, never mind. I guess we don't have to talk about that. I wonder if that changed recently. So I'm going to do it anyway and explain it just in case something strange is happening here. I'm going to cut and paste these because I always forget what these are, and you don't want to see me going back and forth. But there's these two headers that the upgrade and connection headers tend to not get forwarded from Nginx to our app. So if you are using WebSockets in Homework 4, then adding these two lines to forward that upgrade and connection headers may be required. Maybe, I don't know, maybe it wasn't because I just assume that those headers are there on my path. Maybe that's why I got away with that. But if you're using a framework, it's going to want to see these headers, so you have to forward those headers because they're not forwarded automatically. I wonder if we can... I'm not going to bother. But those two headers, usually you need those to get your WebSocket connections working. And speaking of, actually, I have some good questions on WebSockets. I should probably clarify those. If you're using WebSockets for Homework 4, the cross-site request forgery tokens, you would validate the connection. So you do what you can with this. So on every WebSocket message that's sent, you're not going to be able to send the authentication token. You're not going to get those headers. So what you'll do is authenticate, and this is general for WebSockets, you'll authenticate the connection itself. So during the handshake, you do have access to the auth token. You validate the connection and say, this connection is for this user. And then each message they send can have the cross-site request forgery token. You take that token, look up the user for that connection, say, okay, this connection is for this user. Is this the cross-site request forgery token for that user? And if it is, then you can say, okay, we're all good. But you only authenticate the connection and then assume that every message is from that user. Okay, so we got part of the way there, but why I wanted to go into my server, I used my clipboard. What we want to do next is I'm going to go into my terminal. I feel like I haven't typed that in a long time. I'm going to SSH into my server, and we're going to see what kind of configuration we got when we used certbot. So we used certbot and just ran a command, and it did everything for us, everything of AO3. It just did it for us. So let's take a look at what that configuration looks like so we can learn from that for what we want our configuration to look like when we're using our self-signed cert. So I'm going to go into my configuration, and let's cat CSE 312 and take a look at what certbot did for me here. So it's still listening on port 80, the way we have it set up, but we have a little bit different setup here. It's going to redirect using this syntax. If the host is CSE 312, we don't need this conditional because we're just going to redirect all the time. Then it's going to return a 301 with this path. So let's set that part up first. So if we get a request on port 80, we're going to return a 301. And we're going to say, whoa. You need to use HTTPS to connect to us. So we're going to say, go on HTTPS with the same request that you requested here. So we want to use these variables. We don't want to just redirect to the home page. I suppose for your homework that'd be fine. But we're going to redirect to whatever they requested. Host. I seriously have the memory of a goldfish. Request URI. request underscore URI. And then that's going to redirect them to HTTPS. This S right here, very important. If you connect to us with HTTP, we're going to redirect you to HTTPS, and then it's going to handle the 301 response, the location header. Nginx is going to handle all that for us. And then in our other server, we have a second server here. This is where we're listening with 443 using SSL, and this is where CertBot added all of our stuff for us to get our stuff working the way we want. So here, we want to listen. What we want to do, let me stop this, is duplicate this, and our server listening on 80 isn't going to do anything anymore. All it's going to do is redirect to HTTPS. So listening on port 80 doesn't have to do anything. It's just going to redirect to HTTPS. And then on port 443 with SSL, which is going to be TLS, this is where we want to actually handle our request. We're still going to forward requests using HTTP. So between Nginx and our app, that is going to be unencrypted. That's going to be HTTP, but it's all within our server. It's all going to be in the confines of, at most, one server room or one data center. So having that unencrypted is generally okay. It's not going over the internet at large. And then we have all this extra configuration for the SSL. Once you say, I'm going to use SSL, then we need some more information here. CertBot is going to add some extra configuration here. This we don't actually need. CertBot is going to add this to, to make things, to add more configuration that CertBot wants to set up. But we do need this SSL cert and SSL key. So where's our private key and where is our certificate, which is going to be self-signed in our case, but it's still going to be a certificate. So our SSL certificate, SSL certificate key. So we need these two things. We need our cert and our private key added to our configuration if we're going to use SSL. So let's take a look at what this even is. Etc. Let's encrypt live 312. Let's go take a look here. So CD, I'm going to have my leading slash. This is an absolute path. etc. Let's encrypt live. And I can see all of my different sites. I'm going to go into cc312.com and see what I have here. So I have my full chain. What's my configuration? Full chain and private key. So full chain and private key are the two that we're using. Then cert and chain, I'd have to assume that these are the cert and chain for Let's Encrypt, is my guess. Because they're not used in our configuration. Let's see what's in README. Oh my goodness. Did I just type that wrong? Oh yeah, I did. Oh good, it'll break things and shouldn't be used without reading documentation. Well, I'm not reading documentation, so I'm not reusing it. And don't rename the files because, of course, they're pointed to by our configuration. But if we take a look at what the actual things are, so if I do full chain.pem, I'm going to get my certificate. And it's going to have all three certificates. It's the whole chain up until a root CA. And if you, let's see, head. For private.key. And I can see my private key. Not that if I showed the whole thing, I'm sure you wouldn't launch an attack on 312 anyway. But also my private key, which is going to have, as the name implies, my private key. So Nginx is going to need its configuration to point to those two values. That's the necessary part of Nginx setup for HTTPS. And we can take a look at that configuration, the options.ssl Nginx config. Looks like it's all of the encryption schemes that it can use, all kinds of algorithms, some caching information, timeout information, just some basic stuff, basic configuration. I never actually looked at these, so I'm learning here too. I have never had oh my goodness. I thought I typed cat. And some parameters that I can't read. Okay. So my point is, aside from a little extra configuration, CertBot is doing the same thing that we're doing right now, except it actually signed the certificate. It verified that we control the domain name that we said we control. And then it signed our certificate and said, yep, this is a valid cert. And then when it came to the Nginx setup, it's doing the same things that we're about to do here. So we want to do the same thing, but a little different, of course. I'm going to go into my terminal. I'm going to cd into Nginx. I wonder if I can just... I don't feel like doing this the hard way. Hey, all right. I didn't feel like going into the slides to get that command. But trust me, I just ran the command that you don't have to trust me. We can look at it right here. I just ran the command that we have from the slides, exactly as it appears in the slides. I'm going to do US for my country code and then skip all the rest of the questions. And that's going to generate my cert and PEM. So I created these files, my certificate and my private key. These are the files that I just generated, and I want to do a few very careful things here. And I'm not going to forget any of them this time. In fact, I'm going to start with the thing I forgot last time. So step one, I want to copy these files into my container. If I'm doing this setup configuration inside my container, and you probably know by this part of the semester, but the difference between your laptop and inside a container, two completely different environments, and they have to be in sync. Like when you first start doing homework 2, before you get more practice with this, you're wondering why you can't see your uploaded images on your hard drive when you're running your app inside Docker container. It's because those images are being uploaded and saved inside the container. So hopefully we're all used to that by now, but I got to make sure these files get into the container. So cert.pem. And I'm going to be very careful of where I save this. Not very careful, but I have to match where I save this and where I configure Nginx to look for this file. So inside the container, I'm going to choose some place for it, just for the sake of doing something different, I guess. I'm going to save it into my root directory, or my home directory for the root user. So root/cert.pem. And then copy in private key /root private.key. So I'm copying those two files into my container, and then I'm going to go to my configuration and set these file names to the paths where I copy them to inside my container. So I save this at /root with a leading slash, very importantly. This is my certificate, so cert.pem. And then /root/private.key. So that's going to point to those two files, my self-signed cert, inside the container. And hopefully something went wrong, because if everything went right, this will be a short demo. I got too fast at doing this. I probably should slow down. Are there questions about this? Let's build some suspense to see if this will work. Oh, I don't have to build suspense. Actually, Docker's going to build suspense for us. Do we need to include engine? Oh, I already did that. Do we need to set same site strict to our cookie in the homework? If I don't believe so. If it's not in the homework handout, then you don't have to do it. I'll hold myself to whatever's in that handout. I'm pretty sure I didn't add it. I think there's a reason why I didn't add it. I forget all the details off the top of my head. But if it is in there, then let's just check. We'll build a little more suspense on whether that's going to work. Yeah, it's not in here at all. So no, you don't have to do same site strict. Okay, let's go to our front end. Let's check if this works. So first, the one that really should work, we're going to go to 8080. Now this should still work. I'm still mapping 8080 to 8000 inside my container. Everything on that's working with HTTP, not HTTPS. That's how we've been doing things all semester. The moment of truth is when I delete that and try to connect on port 80. What should happen is I get a redirect to HTTPS on port 443, and then I get an encrypted connection, which will give me all kinds of security warnings that this is a self-signed cert. That's what we're expecting. Oh, I didn't go to network. I meant to be on the network tab. So we send our request to HTTP localhost on port 80. We got a 301 response, exactly as we expected. And the location is going to be HTTPS localhost / because we requested the root path. So the redirect is working just as we expected. So that's looking good. We got a redirect for localhost, and things didn't go great. So let's take a look at what happened. The browser is saying, whoa, this doesn't look good. This looks like a self-signed cert. I can't verify that this cert has been signed by a root CA. There's no chain that goes to a root CA. Are you sure you want to do this? And I'm going to say, I don't understand, browser. And then I'm going to have this proceed to localhost unsafe option. And hey, there we go. Did I close this? Back to the network, refresh. And here we have an HTTPS connection on port 443. We are encrypted, and we're connecting to our app in an encrypted way. And if we look at the cert, it is encrypted. We do have a certificate. Here's the algorithm. Where's the public key? Oh, subject public key. Here it is. And there's my public key. That's what's being used to sign my server's part of the shared encryption key. And we have encryption. We have an encrypted app. So to recap, we set up Nginx with a Docker file, copied in any configuration files, our cert and our key, copied all of those files that we need into the container. The cert and private key were generated by OpenSSL, running that command from the slides. Our configuration for Nginx is listening on port 80 and just redirects to HTTPS. On HTTPS, we're listening on port 443 using SSL. We're forwarding everything to my app's service. That service has to match whatever I named it in Docker Compose. And the port has to match the port that we're listening to inside the container. If you want to use WebSockets, you should have these two headers. As we just saw, it worked for me for some reason, but I didn't expect it to. If you don't have WebSockets working, add these two lines to forward the upgrade and connection headers, which for whatever reason aren't forwarded by default. And then make sure you point your Nginx configuration to the locations inside the container where you copied your certificate and your private key And in Docker Compose, make sure you're running your Nginx container and listen on ports 80 and 443 and forward them to 80 and 443 and point to the directory containing your Nginx Docker file. That went too smooth. Usually I run into an issue or two and it takes up the whole time. It went too good this time. I should have purposely made some mistakes there. 80 is the default. If you don't specify a port, I can demo that. If you don't specify a port, you get port 80. If you have HTTPS and you don't specify a port, you get port 443. So HTTPS defaults to port 80, HTTPS defaults to 443. So those are the standard ports. Those are the ports you use all the time when you're surfing the internet, more so 443 these days than 80. If you just go to a website, it's going to use port 443, unless for some reason you're specifying the port, which is pretty shady. I'd feel weird if I went to a site that wanted to use a non-default port, personally. Do we need to add separate paths to the config to make it work on HTTPS? No. I jinxed myself by hoping it was going to go bad, and then it just went so smooth. No, separate paths, not for the homework. For the homework, it's exactly the way I did it. Like, I didn't pull any punches here. That's how you set it up for your homework. Nothing different. If you do, like, separate from the homework, if you want, like slash, maybe your WebSocket is being hosted by a separate service, then you can use Docker Compose to spin up your app, and then maybe a separate app that's just doing WebSocket stuff. You can have Nginx route different paths to different apps. So that's why you would use different servers. Or what I'm doing on my servers is I would have different servers that are listening for different domain names, and then each domain name is going to have separate configuration and forward to a separate service that's running on my server. But you have a lot of power. Like, we're barely scratching the surface of what Nginx can do. Nginx can do all kinds of cool stuff. Most notably, it's used as a load balancer. So if you have 10 instances of your app running on 10 different machines, Nginx can distribute the requests to those 10 apps. So you can handle 10 times the load that a single machine would be able to run. So if you have a server room filled with servers that are all running your one app because you need tons of power because you got millions of users, you could have Nginx distributing the workload among that whole server room to be able to get the job done and host your app effectively. Would a self-signed cert be more sketchy than none at all? I'd say that's a matter of opinion, but I think I'd actually prefer no cert at all. I'd rather prefer no cert than a self-signed cert. Self-signed cert is just like, why'd you even bother? But if there's no cert at all, just be like, they didn't feel like setting it up or something. It's whatever. The self-signed cert would be more, it's hard to say, but it would be more secure, because at least you are encrypting, but you don't have that guarantee that you're not being attacked. But with no cert at all, like any fool running Wireshark, thank you. Any fool running Wireshark can see what you're doing and read all your stuff. So if you have a self-signed cert, at least somebody has to launch a man-in-the-middle attack, which is a lot more sophisticated. But I irrationally would feel better with no cert. Is not a rational belief. Yeah, any other questions? I don't think we need to drag this on, right? If nobody has questions about this, don't come to me with questions later. Now's the time. But if not,